Today we're doing central and inscribed angles, 9.3. We're going to look at two circles. Here the angle is the central angle with its vertex at the center of the circle. On the right we have the inscribed angle. The inscribed angle means that the vertex is on the circle rather than in the center. We already know the measure of the central angle is the same as the measure of the intercepted arc MK. The inscribed angle, though, is not the same. Because the inscribed angle is farther back, its vertex is on the circle, its intercepted arc has a measure of half the measure of the angle. So here's the measure of km. You can see with rounding it's the same as the measure of the central angle. But the measure of arc BN is twice the measure of the inscribed angle. We're going to see why this is tomorrow. So here is the theorem for tomorrow. The measure of an inscribed angle in a circle is equal to half the measure of the intercepted arc. Now we need to know what is the measure of an intercepted arc formed when the angle intercepts the diameter of the circle. So we know that the measure of the arc between the two endpoints of angle A is 180 degrees. We also know that A is an inscribed angle, and so the measure of angle A is half the measure of the intercepted arc. So that means that A is a 90-degree angle. And here is our corollary regarding right angles. And finally, we want to talk about the relationship between two angles that intercept the same arc. Angle D intercepts arc CA, but so does angle B, also intercepts arc CA. So because we know that the measure of angle D is 50, the measure of arc CA is twice that, or 100 degrees. But look, angle B is also an inscribed angle that intercepts the measure of arc CA. And so to find the measure of angle B, we work the other way. We take 100 degrees for our intercepted arc, divided by 2, and the measure of angle B is also 50 degrees. So angle B and angle D are congruent. And that's our last theorem for today. One more thing we're going to do is review the radii of, to review isosceles triangles formed by the radii. So here we have circle C, and segments CB and AC are both radii. That means they're congruent, and we have an isosceles triangle. So then what we're going to do is look at the measure of angle A. It's also 31 degrees because the base angles of an isosceles triangle are congruent. And then we need to find the measure of angle C. To find the measure of angle C, there's 180 degrees in the triangle. Minus 31 minus 31 degrees. That's 180 minus 62. And for the final answer we get, help me out here, 118 degrees. All right, folks, make sure to bring your notes to class tomorrow, and we'll go over any questions that you have then.